There's a ghost planet in our solar system. It's always nearby, but almost invisible. It hides right where the sky shines brightest, in the blinding glare of the sun. Ancient astronomers caught glimpses of it only as fleeting sparks in the morning or evening twilight, a swift, elusive messenger of the gods, appearing for a few moments before vanishing again. This is Mercury, and it's not just hiding, it's shielded by a wall of pure light. Our greatest eye in the sky, the Hubble Space Telescope, can peer 13 billion years into the past, right back to the birth of the very first galaxies. Yet, it refuses to look at Earth's closest neighbor. The Hubble team has never aimed it at Mercury. The reason is simple and harsh. Trying to focus on that planet is like staring at the sun through a giant magnifying glass. The direct sunlight reflected off Mercury's surface would pour into its mirrors and fry the sensitive electronics. It would blind the most expensive astronomical instrument humanity has ever built. Forever. The planet we might study best remains off limits. Today, we'll explore why this scorching world stands as the most challenging mystery in our solar system. Step by step, we'll journey from the earliest nearly blind observations to daring robotic missions that risked everything to touch the forbidden. You'll see how engineers solved problems that even the Hubble Space Telescope couldn't, and discover the shocking revelations waiting at a planet with a massive iron core and glaciers inside boiling craters. Its proximity to the sun makes Earth-based observations almost impossible. Mercury only appears in a narrow window, just after sunset or right before dawn, hanging low on the horizon, trembling through thick layers of atmosphere. But these fleeting glimpses don't answer the big questions. If we can't safely observe Mercury from Earth, how did humanity manage to peel back its veil of mystery? And what extreme conditions greeted the first brave explorers? To uncover the secrets of this planet, scientists had to literally close their eyes. The first real breakthrough didn't come from telescopes, it came from radio waves. Instead of trying to look at Mercury, they started to listen. They aimed powerful radio signals at the planet, turning it into a giant mirror. When the reflected waves bounced back to Earth and got processed, the numbers left everyone stunned. The day side heats up to over 800 degrees Fahrenheit, hot enough to melt lead and make it flow like water. But as soon as the planet slips into shadow, temperatures plunge to minus 260 degrees Fahrenheit. That's a swing of nearly 600 degrees. Imagine stepping out of a blazing furnace and straight into a tank of liquid nitrogen. And in the polar craters where sunlight never reaches, the cold sinks even further, to about minus 300 degrees Fahrenheit. What emerges is not one planet, but two fused together. A fiery hell on one side and a frozen wasteland on the other. Numbers on paper tell one story, but real images reveal something entirely different. In 1973, they sent the first spacecraft to Mercury, Mariner 10. A direct path was impossible. The sun's powerful gravity would have dragged the probe straight into its fiery depths. The solution came from an Italian astronomer named Giuseppe Colombo, known to everyone as Bepi. He designed a clever trajectory. Mariner 10 first flew close to Venus, using its gravity to slow down, shedding extra speed. Only then did it set course for Mercury. This was the first ever gravity assist maneuver in spaceflight history. The spacecraft never entered orbit. Instead, it flew by Mercury 3 times, capturing just 45% of the surface. The images came back grainy and black and white, but they clearly showed a cratered landscape, astonishingly similar to the Moon's. The rest of the planet remained a vast blank white spot. Filling that gap became the mission of Messenger. Launched in 2004, it was the first to orbit Mercury, spending several years mapping the entire surface. Along the way, it confirmed the presence of ice at the poles. But each new mission didn't just answer old questions, it uncovered even more mysteries. To get to the truth, on October 20th, 2018, humanity launched its most complex spacecraft ever sent to the inner planets. This joint effort from the European and Japanese space agencies carries the name Bepi Colombo, honoring the Italian scientist whose calculations once paved the way for Mariner. In fact, it's not a single probe, but a pair of independent spacecraft. The European module will map the surface in fine detail, while the Japanese craft studies the planet's invisible magnetic field. Together, they aim to peer deep beneath the surface, unravel the planet's strange composition, and finally understand why its core takes up so much space. Staying close to a planet where metal literally melts pushes the limits of what's possible. The Bepi Colombo spacecraft looks like a cosmic thermos, wrapped in layers of ceramic insulation. But overheating is just part of the challenge. The real nightmare for engineers is the sun's gravity. It constantly tugs the probe inward. To avoid plunging straight down, the spacecraft must keep firing its thrusters. This burns through resources so fast that the fuel ends up weighing more than half the entire launch mass. Think of a race car whose fuel tank weighs more than its engine and chassis combined. Each of the two modules fights the heat in its own way. The European side keeps one face locked on the sun, hiding behind a massive heat shield. The Japanese module takes a different approach. It spins continuously at 15 rotations per minute. Like a skewer turning over a campfire, this constant motion stops any single spot from overheating and burning up. On its very first flyby, Bepi Colombo passed just 124 miles above the surface, even closer than the International Space Station orbits Earth. Those initial black and white images were just a test, a reconnaissance mission. Yet, combined with archives from earlier explorations, they already form a remarkable puzzle. Before us lies a world full of contradictions, a planet with a massive iron core, crisscrossed by fractures the size of entire continents, hiding trillions of tons of ice in places where physics says it simply shouldn't exist. When the reconnaissance probes finally pieced together a complete map of Mercury, humanity saw its face for the first time. And it looked familiar. The surface is scarred by countless impacts, like an ancient parchment etched with history. Names we've known since childhood mark its landscape. Lermontov crater stretches 166 kilometers across. Haydn is even larger, 251 kilometers in diameter. Then there's the giant Raphael, spanning 342 kilometers from edge to edge. These aren't just dents. They stand as monuments to a cosmic bombardment that raged for billions of years. But among thousands of craters, one outshines them all. The Caloris Basin. The impact that created it was so immense, it left a scar over 1,550 kilometers wide. This isn't just a crater, it's an entire province scorched by a single blow. If an asteroid like that struck Europe, the crater would stretch from Paris to Warsaw, and the shockwave would circle the entire Earth. But the longer Messenger studied this ancient surface, the stranger the details that emerged from the shadows. At the center of one crater, it found something unlike anything else in the solar system. A formation geologists nicknamed the Spider. From the central 40-kilometer-wide crater, hundreds of straight grooves radiate in all directions, like a giant insect stretching its legs across the planet. These aren't impact cracks, they formed later. They're not riverbeds. Mercury has never had water. This is a geological anomaly, one whose origin still remains a mystery. And this isn't the only oddity. Scattered across the planet are more than 100 sites where ancient volcanic explosions broke through the crust from within. Mercury isn't a dead rock. It was once a living, breathing world with a fiery interior. This cracked, scarred, and sun-baked surface is just a thin shell, the skin of a planet. But Mercury's greatest secrets don't lie on the surface. They hide far beneath it. And the first one defies all logic. On the day side, where temperatures soar to more than 430 degrees Fahrenheit, any metal melts into a pool. The sun blazes here with 11 times the intensity it has on Earth. This is the hottest furnace in the entire solar system. And right here, in this inferno, the Messenger spacecraft discovered water. Not a hint, clear proof. Trillions of tons of water ice hide in craters at Mercury's poles, where eternal night reigns. Ice. On the doorstep of the sun. In a place where lead would flow like a river. This paradox feels unsolvable. But the explanation is simple and elegant. Mercury's axis barely tilts, so sunlight never reaches the floors of its deep polar craters. For billions of years, temperatures there have stayed at minus 183 degrees, a perfect natural freezer. Comets crashing into the planet brought water, which found refuge in these icy traps. Yet this discovery opened the door to an even deeper mystery. Data from Mariner 10 in the 1970s revealed that Mercury is an unusually dense planet. The spacecraft Messenger dug deeper and confirmed the hunch. Mercury's core makes up 83% of the planet's total mass. This isn't just a rocky ball with an iron center. It's a massive sphere of molten iron and nickel, barely covered by a thin layer of silicate crust. It's as if someone took a planet the size of Earth, stripped away the entire mantle, and left only the blazing core behind. Even more surprising, this molten core generates a magnetic field around the planet. It's about 100 times weaker than Earth's, but it exists with a distinct north and south pole. For a small, slowly spinning planet, that defies all expectations. It's like finding a wristwatch with its own moon. Something in Mercury's past went very differently than its neighbors. The Messenger probe searched for answers to all these questions. For 11 years, it orbited over scorching rocky plains, mapping the terrain, analyzing its composition, and peering into the perpetual darkness of craters. On April 30th, 2015, its mission came to an end. The fuel ran out. The final command from Earth sent the probe on its last flight. Traveling at 14,000 kilometers per hour, it smashed into the surface, creating a new man-made crater 17 meters wide. Located at 54 degrees north latitude and 210 degrees east longitude. The explorer became a permanent part of the world it had studied. A massive iron core and ice in the craters? These are all remnants of an ancient catastrophe. But how do you unravel that mystery when the key isn't something you see, but something you have to hear? A massive iron heart and ice trapped in boiling craters? These aren't just oddities, they're clues. Fingerprints left behind at a crime scene that played out billions of years ago. The leading theory that explains all these anomalies reads like a cosmic thriller. The Mercury we see today is not a whole planet. It's what's left of one. A survivor. In the early, chaotic days of the solar system, before orbit settled, there was a proto-Mercury, a much larger world, wrapped in a thick mantle of silicate rock. Then another body crossed its path, a collision of unimaginable force. The impact wasn't head-on but glancing. It didn't shatter proto-Mercury into pieces. It did something far more brutal. It stripped away nearly all of its crust and mantle, like peeling the skin and flesh off a giant fruit, leaving behind just one enormous blazing core. Billions of tons of vaporized rock were blasted into space, swept away forever by the solar wind. What remained, the exposed, ultra-dense core, cooled slowly, cloaked in a thin new crust. This catastrophe explains everything. It's the reason Mercury's core holds more iron than any other planet in our solar system. We're looking at a remnant, a shadow of former glory, a world that survived its own destruction. For decades, this story unfolded through spectral analysis and computer simulations, a tale of fury and fire. But the next chapter didn't come through a telescope. It arrived through speakers. A new mission took over from Messenger, Bepi Colombo. Its instruments didn't just observe, they could also sense. On October 1st and 2nd, 2021, during a close flyby, the spacecraft detected something unusual. Invisible vibrations, fluctuations in the magnetic field, and streams of charged particles surrounding the planet. This wasn't sound as we know it. Nothing can carry sound in a vacuum. Instead, it was raw, unfiltered data encoded in the language of plasma physics. Scientists set out to translate it into something we could understand. They took these signals, vibrations too faint for human ears, and transformed them into a soundtrack. This process is called sonification. It's a form of scientific artistry, a way to listen to the whispers of the universe. The result sounds unlike anything from Earth. It's not music, and it's not noise. It's a hum of emptiness interrupted by crackles and whistles, the shudder of a spacecraft tearing through an invisible web of magnetic fields, a real soundtrack capturing the interaction between a man-made object and a world forged in fire. For the first time, we heard the echo of that ancient catastrophe. The mysteries of Mercury pushed us to look back billions of years into the past. But to understand its present, we have to turn to its neighbor, the one that rules everything here. And one Earth spacecraft is already heading straight into its embrace, into the very heart of fire, where temperatures soar to 3 times hotter than Mercury's surface. Mercury's extreme temperatures and its blazing hot surface seemed like the ultimate boundary, a physical limit beyond which pure madness begins. But that was just the entrance to hell. The real inferno lies closer. And our boldest messenger is already heading there, the Parker probe from the American Space Agency. This is a kamikaze spacecraft, tasked not just with studying the sun, but diving right into it. Its heat shield must withstand temperatures soaring up to 1400 degrees Celsius. That's 3 times hotter than Mercury's sunlit side where lead melts. Hot enough to turn steel into liquid. Parker is flying into a place where the very idea of matter starts to lose meaning. Surviving such intense fire seems impossible. Any armor would vaporize in seconds. But engineers found a clever solution, not by brute force, but by outsmarting the problem. Saving the Parker isn't about building a thick wall, it's about creating an almost complete void. Its shield, its sunshade against the star, has 3 layers. The outer layer is a thin ceramic that reflects light. Inside, there's another protective layer. Sandwiched between them lies 11 centimeters of carbon foam that's as light as air. This material is 99% vacuum. It weighs almost nothing and barely conducts heat. The intense heat simply can't break through that emptiness. Thanks to this brilliant trick, while the outside faces a blazing 1400 degrees, the sensitive instruments inside stay at a comfortable room temperature. In November of 2021, this daring feat succeeded. The Parker spacecraft, speeding at hundreds of thousands of kilometers per hour, drew within 8.5 million kilometers of the Sun. And it did something extraordinary. It touched the star. This isn't a metaphor. There's a real physical boundary separating the Sun's atmosphere from interplanetary space, called the Alfvén surface. It marks the point where the solar wind breaks free from the star and begins its endless voyage. Crossing it is like stepping into water, not just standing at the shore. And Parker crossed it, not just once. 3 times it passed beneath this invisible line, plunging into the Sun's boiling corona. For the first time in human history, a man-made object entered the atmosphere of another star. This triumph stands alongside the first steps on the Moon. Diving into the Sun's atmosphere paid off immediately. The Parker Solar Probe confirmed a long-held theory. Very close to the star, less than 6 million kilometers away, lies a zone almost completely free of cosmic dust. Tiny particles from asteroids and comets, which fill the entire solar system, simply can't survive here. The intense radiation heats them to boiling point, turning them into gas as they evaporate. The probe flew through this sterile void, a region cleansed by fire. This discovery reshapes our understanding of how planets formed, including Mercury. It was born and raised in an environment where matter itself constantly struggled just to exist. Humanity reached out and touched the heart of our solar system, all without leaving our small blue planet. The Parker Solar Probe survived the Sun's fiery embrace. It plunged into the Sun's atmosphere and emerged, carrying data straight from the inferno. It sensed what Mercury has endured every day for billions of years. We touched a star. But what did the probe actually see and feel inside the boiling plasma of the solar corona? What secrets about the origins of space weather did it uncover by venturing into its very source? Plunging into the heart of a solar storm, the Parker probe witnessed something that had existed only in theory until then. It saw the whip, an invisible weapon the star uses to unleash its fury across the entire system. For decades, physicists puzzled over a mystery. Why does the solar wind speed up as it moves away from the Sun, defying the laws of gravity? Parker provided the answer. It captured the process in action. The star's magnetic field isn't a flat web. It consists of 2 types of lines: closed loops that rise from the surface and curve back like giant arches, and open lines that stretch endlessly into space. Sometimes in active regions, these open and closed lines come into contact. A short circuit occurs, magnetic reconnection. In that instant, enormous energy bursts free. The closed loop breaks away and flies off, while the open line snaps back sharply, like a tightly stretched rubber band finally released. In the spring of 2022, Parker recorded the aftermath of this process near the region called AR12972, a perfect S-shaped kink in the plasma. This is the crack of the whip, flinging powerful streams of particles away from the star with incredible force. This cosmic mechanism isn't just elegant physics, it's the root cause of space weather, a force that directly shapes our daily lives. Every blast it sends out poses a threat to satellites, the backbone of navigation and communication. It endangers power grids back on Earth, which can overload under torrents of charged particles. It puts astronauts in orbit at risk. Understanding how this solar wind forms and gains destructive speed holds the key to building early warning systems. Systems that can predict a storm days before it strikes, rather than just registering the impact after the fact. Diving straight into the heart of the tempest, the Parker mission has given us eyes to spot the approaching storm. It teaches us to listen to the stars' whispers before they burst into a roar. The greatest discoveries often come from the most unexpected places. Parker's solar probe was designed to study the sun, but to reach it, the spacecraft had to slow down using the gravity of another planet. That planet was Venus, Earth's sister, forever cloaked in an impenetrable blanket of sulfuric acid clouds. For decades, its surface remained a mystery, accessible only through radar maps. No one expected Parker to see anything. Its cameras were built to capture plasma, not planetary landscapes. Yet during one flyby, the engineers decided to take a chance. What they saw changed everything. Through the thick veil of clouds, a faint, ghostly glow emerged. This wasn't a trick of light. It was the glowing, scorching surface of Venus itself. Its own heat was strong enough to pierce the atmosphere in visible light. For the first time in history, humanity saw the continents and plains of another planet. Not on a radar screen, but almost with its own eyes. A spacecraft built to study the brightest object in the sky gave us the clearest glimpse of one of the most hidden worlds. This flyby gave us more than just a new image. It revealed a new sound. Space is often called silent, but sensitive instruments on the Parker probe capture an unending roar. Not sound in the usual sense, but vibrations recorded as noise. The sensors pick up the hiss of plasma waves, the breath of the solar wind. Yet there's another much sharper sound, the crackle of micro-impacts. Traveling at nearly 435,000 miles per hour, the probe speeds through a cloud of cosmic dust. Each tiny particle striking the hull triggers a miniature plasma explosion. Instruments record these as sharp clicks. Thousands of clicks every minute blend into a steady white noise. This is the sound of relentless bombardment, a sonic backdrop that starkly contrasts with Venus's majestic, silent glow. The same spacecraft revealed two faces of space, its hidden beauty and its constant microscopic fury. The Parker probe survived a collision with a coronal mass ejection and keeps pushing toward the heart of the solar system. Its final moments will be nothing short of fiery, but the hottest place made by intelligent beings isn't in space. It lies beneath the Earth's surface, in Switzerland. Beneath the border between France and Switzerland, buried deep underground, lies a 27-kilometer ring of superconducting magnets. Inside it, we have built our own star, not to produce light or heat, but to peer into the very beginning of history. We have long known absolute zero, the chilling temperature of negative 273.15 degrees Celsius. At that point, atoms come to a standstill and complete thermodynamic silence takes over. But does heat have an upper limit? Theorists say yes. It's called the Planck temperature, a number with 32 zeros, where the very fabric of space-time should tear apart. A striking figure on paper, yet human experiments have pushed far beyond this threshold. Deep inside the collider, scientists accelerated lead ions to nearly the speed of light, then smashed them head-on. For a mere trillionth of a second, the impact unleashed a state of matter unseen in the universe for the past 13 billion years. Temperatures soared to 10 trillion degrees, hundreds of thousands of times hotter than the sun's core. But it wasn't metal that melted. Atomic nuclei themselves dissolved. Protons and neutrons broke apart into fundamental building blocks, creating a primordial soup of quarks and gluons. This is the very substance from which our universe was born during its first microsecond after the Big Bang. We didn't just ignite the hottest fire on Earth. For a fleeting moment, we turned back time and recreated the act of creation. Our underground inferno is nothing but a matchstick compared to the true cosmic furnaces. Let's journey to the Wolf-Rayet star number 102. This giant sheds its outer layers, revealing a blazing core. Its surface burns at 210,000 degrees. Impressive, but we're just getting started. Next comes the birth of a neutron star. When a massive giant collapses, its core compresses to insane densities. The entire mass of our sun squeezed into a sphere the size of a typical city. At that moment, temperatures soar past 100 billion degrees. And even that isn't the limit. At the centers of distant galaxies reside real monsters, devouring entire star systems. Take Quasar 373. Matter falling into a supermassive black hole heats up from friction to 40 trillion degrees. That's 4 times hotter than our underground record. Humanity's most powerful tools pale against this gravitational meat grinder in the heart of an ancient galaxy. The higher we climb this temperature ladder, the more elusive the very concept of temperature becomes. Physicists only use this term for systems in equilibrium, where energy spreads evenly. But what kind of stability exists inside a tearing supernova? Or in the torrent of matter being shredded by a black hole? We hit a fundamental dead end. If quarks are truly elementary and can't be broken down any further, where does the energy go? This isn't just a physical barrier, it's the edge of what we understand. It turns out that the universe's absolute maximum temperature isn't a fixed number. It's a boundary beyond which our knowledge simply runs out. And compared to that, the fate of the Parker probe, eventually melting and dissolving into the solar plasma, feels like a small local story. The real hunt for ultimate heat leads us to laws we have yet to decode. Temperature is just one form of cosmic brutality. Another is motion. To truly grasp how fierce storms can get beyond our atmosphere, we first need to return to Earth itself, right into the heart of a tornado. A tornado on Earth marks a starting point. It stands as our standard for fury. It doesn't form from an ordinary cloud, but from a monster known as a supercell thunderstorm. Inside this colossal cloud, towering 10 kilometers high, an invisible column of air already spins, a giant vortex. It hangs in the sky, gathering strength, unseen by those below. Then comes the crucial moment. A surge of icy air rushes down from above. Instead of weakening the vortex, it squeezes this invisible column like a massive hand, forcing it to accelerate. The funnel grows thinner, denser, faster. Finally, it touches the ground. In that instant, the tornado is born. A perfect machine of destruction, crafted by our own atmosphere. Beyond Earth, this machine looks like a child's toy. On Jupiter, a storm rages, the Great Red Spot. But this isn't just any storm, it's a hurricane more than 1 1/3 times wider than our entire planet. Not just a hurricane on a planet, but a hurricane that could swallow the whole planet, whole, and still have room left over. It has raged for centuries, an eternal eye staring out into space. And it's not a shallow phenomenon. Its roots plunge deep into Jupiter's atmosphere, 100 times deeper than Earth's deepest ocean. Compared to it, Earth's oceans are just a thin film of water on an orange. Recent observations reveal the giant is weakening, its size slowly shrinking. But even fading, it remains a titan. Nearby, on Saturn, lightning tears across the skies. Each flash packs 10,000 times the power of the strongest thunderstorm on Earth. A single bolt releases enough energy to power an entire metropolis for a month, in just a fraction of a second. Scale is one thing, but some worlds hide horror in their very weather chemistry. Venus, Earth's sister planet, its sky cloaks itself in thick yellowish clouds. But these clouds aren't made of water vapor. They consist of concentrated sulfuric acid. From these clouds, acid rain really falls. Drops of this caustic acid begin their descent toward the surface. Yet they never reach it. The air near the ground heats up to 465 degrees Celsius, hotter than a pizza oven. The acid rain evaporates before it touches the ground, turning into poisonous steam. An eternal trick. An endless cycle of deadly precipitation, born and dying in the blazing atmosphere, never touching the cracked, lifeless surface below. And yet, there's a place where the wind surpasses everything we've ever seen. The farthest giant in our solar system, Neptune. A frozen world, wrapped in a blue haze. Here, the fastest winds in the entire solar system blow. They reach speeds of 2,000 kilometers per hour. That's 1.5 times faster than the speed of sound. Winds outrunning their own roar. A stream of gas moving faster than a bullet fired from a rifle. This supersonic hurricane never stops. It circles the entire planet. In images, you can see vast dark spots. Massive storms the size of continents, born and fading away in icy fury over just a few years. Weather pushed to the absolute edge of speed. Supersonic winds on an ice giant. Acid rain on a blazing hot planet. But the strangest weather systems unfold on worlds where the very foundation of life is different. Where dust devils roam deserts and rain falls not as water but as liquid gas. Water, acid, gas. We're used to thinking of weather as a dance of liquids and vapors. But some worlds fight their own battles in the atmosphere, wielding solid weapons. Mars doesn't have rain, it has suffocation. Every so often, the entire planet plunges into a war fog. A global dust storm lifts billions of tons of fine, rusty particles into the air. This isn't just a storm, it's a slow fading of light. The sky shifts from pale blue to orange, then to a bloody red, and finally to impenetrable darkness. For the rovers on the surface, that means certain death. Solar panels stop working. For months, the whole planet vanishes beneath a thick, choking shroud. Even when the storm dies down, its ghosts roam the deserts, tall, twisting columns known as dust devils. They silently glide across the dead plains, the only movement in a frozen world. This weather carved from stone might seem like the ultimate oddity, but it's not. Far beyond the asteroid belt in Saturn's frozen domain orbits Titan, a world shrouded in a thick orange haze. At first glance, it almost comically resembles Earth. There are clouds. Rivers flow into seas, and it rains. But look closer, and the familiar picture crumbles to dust. Titan's atmosphere is so dense and its gravity so weak that raindrops fall agonizingly slowly like a dream. They don't splash on the surface. Instead, they drift down lazily like flakes of wet snow. And here's the kicker, it's not water, it's liquid methane, icy burning natural gas. Methane clouds pour out methane rains, filling methane lakes. One of them, Kraken Mare, covers a larger area than all the Great Lakes of North America combined. It's a complete hydrological cycle, a mirror image of Earth's. Only this entire system runs on a substance we use on Earth to boil a kettle. Dust storms, methane downpours. These are the tempests on the edges, but the true absolute storm rages at the center, right on the sun itself. This is where weather phenomena are born, ones that dwarf any planetary disaster. These are fiery tornadoes, massive solar prominences twisted by magnetic fields into monstrous whirlwinds of pure plasma. A column of fire can reach 120,000 kilometers high. Imagine stacking 10 Earths on top of each other. The vortex starts at the star's surface and stretches out into space, reaching a third of the distance to the moon. Inside this beast, streams of superheated material race at 500,000 kilometers per hour. That's hundreds of times faster than a sniper's bullet. Fast enough to travel from Earth to the moon in under an hour. This isn't wind. It's matter transformed into a weapon of unimaginable power. Dust storms that bury entire worlds. Freezing rains of flammable gas. Fiery whirlwinds spanning the size of 10 planets. Yet all of this is just a piece of one colossal machine that started running 4.5 billion years ago. It's time to uncover how it all came together. All this fury, all these extremes, from the icy rains of Titan to the fiery storms of the sun, follow a single script written 4.5 billion years ago. It began quietly, a shapeless cold cloud of pure hydrogen drifting through the void. But inside it, an unstoppable force was already at work, gravity. For millions of years, gravity squeezed that cloud, pulling it inward, compressing it into a giant cosmic whirlpool. At its center, pressure and temperature climbed with every passing moment. A star's embryo was taking shape. When its mass grew to 80 times that of Jupiter, everything changed. The core collapsed, nuclear fusion ignited, and our sun was born. We know this is true because we see the process happening right now, in the Orion Nebula, in the star nursery around the young star H.L. Tauri, new worlds forming before our eyes. The remnants of this primordial cloud that the star didn't swallow flattened into a vast spinning disk. Here, the fundamental law of sorting took hold. Near the young, blazing star, the heat was unbearable. Only the toughest materials could survive, refractory rocks and metals. From this molten dust, clumping grain by grain, small, dense worlds were born. Mercury, Venus, Earth, and Mars. But beyond an invisible line of cold, conditions changed completely. It was cool enough for not just water, but gases too, to freeze. Billions of icy chunks called planetesimals began to clump together, growing fast into enormous snowballs the size of planets. Their mass grew so huge that their gravity acted like a cosmic vacuum, pulling in trillions of tons of hydrogen and helium straight from the disk. This is how the gas giants formed. The picture looks flawless, elegant, it explains everything. Too perfect. Because within this elegant mechanism lie parts that just don't fit. Clues that unravel the whole story. According to the theory, all planets formed from a single spinning disk should rotate in the same direction. Almost all do, except for two. Venus spins backward, as if rewinding time. And Uranus? It's tilted on its side, rolling along its orbit like a tipped-over barrel. These anomalies aren't small glitches, they crack the very foundation of what we understand. The nebular hypothesis in its pure form can't explain them. And that's the biggest unsolved mystery in modern planetary science. Maybe the answer lies in the echo of a catastrophe we've already seen with Mercury. Perhaps in the early days of the solar system, during the era of cosmic bombardment, massive collisions knocked Venus off balance, forcing it to spin the wrong way. And they tipped Uranus over forever. Order arose from chaos. But the scars of that chaos remain visible today. All these mysteries, from Mercury's scorched heart to Uranus's flipped world, exist only for a fleeting moment. The star that gave birth to this system will one day reclaim it. When its core runs out of hydrogen fuel, the balance of forces will collapse, and the sun will swell into a crimson sphere, a red giant. Its expanding atmosphere will swallow Mercury's charred remains, wiping it off the cosmic map. It will reach Venus, vaporizing its acidic clouds and melting its surface. Earth's fate hangs by a thread. It will either be consumed or reduced to a lifeless, scorched rock, frozen at the edge of a dying star. This isn't speculation, it's physical inevitability. The final chapter written in the laws of thermodynamics. And in the face of this ending, all our searches, discoveries, and unanswered questions become part of something greater. We are just a brief moment when the universe looks back at itself before turning the page.